So we're here at our display home. We've just completed our blower door test. So with our blower door test, we're aiming for the passive house rating. So that's measured in air changes per hour. So for a passive house, we're looking for 0.6 air changes per hour. With that, we've got to seal up the building really tightly for that. And so if you compare that to standard construction, could it be anywhere between 10 to 20 air changes per hour? So there's a fair significant difference between the two. With this construction, as you can see behind me, we've used the Intello Pro Climber product on the internal walls. So that's a membrane where we run that on all the external walls on the inside, and we seal every aspect of that, and that allows us to seal the house up to that air tightness level. To do that, we tape all our joins, so we've got all our joins taped. Any penetrations that we have through it, so whether it's a wire or a pipe or something, we've got to make sure that that's all sealed off well, and we can show you images of that as well as to how we've sealed that off. So during the testing process for the blower door test, there's a couple of things we have to do. So with the way they test with the blower door, there's two tests they do. One's to pressurise the build, so push air in and create a pressure inside the building, and then there's a depressurise where they turn the fan around and they draw the air out, creating a suction. And that puts the test on things like windows and our membrane in two directions, causing the different challenges for it. So it allows it to get an average rating, which here we were able to get 0.58, which was a really good reading first time without having to do any touch-up works. During the test process, the other things you use for any small leaks and faults that you might be looking for within the internal membranes or the build is they have two options. They have a thermal imaging camera, which they're used to see any changes in temperature, usually on the depressurizing test, because they can see cool air being drawn into the warmer environment inside. The other option you have is little smoke machines, which create a little puff of smoke, and then you can see that smoke be drawn to where the air is moving through those little leaks. So there's a couple of options of finding faults within your airtight membrane. The other one is feeling for drafts, but that's a bit harder to do. Using the thermal imaging camera at least gives you somewhere to look at for the fault, and then you can find it a bit easier with that solution. So with installing this membrane, there are a few things we just discussed about penetrations through it. So here we've got an external light wire that we've got to create a penetration through this, but then also be able to seal it around. So we've got a gasket here that we fit around the conduit penetration, and then where the wire goes through the conduit, we seal that off with the Orcon sealant. That creates an airtight seal so that when we do our blower door test, that it passes that without having any air leaks. You'll also note that we've got timber battens on top of the membrane that allows us to install our plaster over the top and still have our services run within that cavity. Another thing to consider when we are doing a building to this air tightness level, that you've got to be able to install a ventilation system. So anything below roughly the 5 air changes per hour, you should be considering a ventilation system so that you've got enough fresh air to run the home appropriately. For us, we use heat recovery ventilation systems because our house is so well sealed and so well insulated that we are just looking to maintain the temperature that we have within the building, and the machine does that really well with its air change, heat exchange scenario within the unit, and that is super efficient. So it's mostly just running the fan to push the air around the building, and the heat exchange is done through a simple scenario within the unit without any mechanical intervention.